So finally, we are down to our last step of our full simple linear regression analysis, which is the hypothesis test. Hypothesis test. So first, as we all know, for step 1, we need to dictate or state our HO and HA. So even though there's no claim, we can just simply say that our HO is beta sub 1 is equal to 0, and our HA, or alternative beta sub 1, is not equal to 0. Now some of you might be thinking, will we not use our beta sub 1 hot, which is equal to 3? Now, the reason why is that we are trying to prove that this is actually whether it has a significant difference or not from 0 based on the data that we actually have. So is this significantly different from 0 based on our data? So let us see. Now, I just showed early how to do these tables in Excel, but actually these are actually steps 2 and 3. So these are actually steps 2 and 3 of our hypothesis test. Now that we have this, we need for step 4 our p-value. And our p-value can be found here and here. So let's just take a closer look. Our p-value is 0.01154. So in 2 decimal places, 0.01. And by default, if nothing is stated, then our alpha will be equal to 0.05, especially if nothing is stated. So, since here our p-value is equal to 0.01, if we compare it to 0.05, we know that this is smaller than 0.05. Therefore, we shall reject our null hypothesis. And since we are rejecting our null hypothesis, we are saying that this is significantly different from 0. Therefore, we can say that there is sufficient evidence to reject HO. Thus, there is a significant relationship between dexterity and productivity. So the entire regression analysis, we were able to tell that there is a significant relationship between dexterity score and productivity, and that significant relationship has a very strong relationship based on our R and R squared. And that relationship that is significant and very strong is described by this equation, that the estimated productivity or productivity hot is equal to 19.2 plus 3 times your dexterity score. So that is how we do a full, simple, linear regression analysis.